Okay, let us learn the stability of colloids. Before going to the details of stability of colloids, one of the important word which we have to familiarize is coagulation. Coagulation is the process which occurs when a colloid lost its stability. So coagulation means in some certain cases the colloidal particles aggregate together and settle down. Aggregates and settle down. And the process is known as coagulation. So coagulation is the phenomena of flocculation and settling down of discharged colloidal particles. Discharged colloidal particles. So what are the factors which helps the colloid to be stable? That is, helps from the process coagulation. Two factors are there. One is like charges of the colloidal particle. Like charge of colloidal particles. And the second one is the presence of solvent layer around the particle. Presence of solvent layer around the particles. Around the colloidal particles. These are the two factors which prevent the colloidal particles to be coagulated. So the first one is like charge of the colloidal particles. So we know in a colloid, all the colloidal particles possess same charges. That is, if it is a positive colloid, then all the colloidal particles having positive charge. If it is negative, then all the particles have negative charge. So due to the presence of this like charges, there is a repulsive force which arises between these particles. So what happens? These colloidal particles will not aggregate and will not coagulate. And the two important factors which determines the extent of coagulation are, one is the magnitude of the charge of the colloidal particle. One is magnitude of the charge of the colloidal particle, and the second point is the thickness of the double layer. So how magnitude of the charge helps to prevent coagulation? That is, if the repulsive force between these particles is very high, then that will never coagulate. Coming to thickness of double layer, if the thickness of the double layer is high, that is, if the theta potential is high, then coagulating power, the extent of coagulation will decreases. Extent of coagulation will decreases. So what happens there is, if the thickness is very high, thickness is very high, then coagulation can be prevented by the double layer. So slow coagulation. But when the thickness is very less, coagulation occurs easily coagulated. The reason behind this is when thickness is very low, their van der Waals forces, the extent of van der Waals forces greater than the electrostatic repulsion. When the magnitude of electrostatic repulsion is lesser than van der Waals force, then coagulation occurs very easily. But in the case of thick double layer, van der Waals forces, the extent of van der Waals, the magnitude of the van der Waals force is lesser than the electrostatic repulsion. So coagulation will happen only very slowly. Then moving to the second factor, that is presence of solvent layer around salt particles. Here, in addition to the charge of the particles, a solvent layer is present. Solvent layer is present on the surface of the colloidal particle. Colloidal particle is bound with a layer of solvent. And this layer of solvent acts as a barrier which will not allow the interaction of the particles, which leads to the coagulation. So this acts as a barrier and coagulation will be prevented by this layer. For example, consider gelatin. Gelatin is a negative colloid. And normally gelatin is bonded, the particles of gelatin is bonded with water. So if we add any coagulating substance, for example, if we add sodium chloride, Na plus ions are there. If Na plus ions will interact with this gelatin, then that will coagulate. But the solvent layer present on the surface of this gelatin particles will prevent the interaction of Na plus ions with the gelatin. And the process of the formation of solvent layer on the surface of the colloidal particle is known as solvation. Usually the process solvation is observed in lyophilic colloids. In the case of lyophobic, only light charge helps them to stable. That is why lyophilic colloids are more stable than lyophobic. Then, what are the methods which are used to coagulate a colloid? Methods of coagulation. The important methods are, the first one is addition of excess electrolyte. Then the second method is mixing of two oppositively charged colloids. Then by mechanical methods, by boiling. Then fourth one by boiling. The last method is prolonged dialysis. So first one is addition of excess electrolyte. We know a colloid is prepared by adding suitable amount of electrolyte to the colloidal particles. But if excess of electrolyte is added into the colloid, what happens is, well, the electrolyte added to the colloid is having an opposite charge with respect to the colloidal particle. So what happens if excess of electrolyte is added into this colloid, that electrolyte particles will interact, the oppositively charged electrolyte particle will interact with the colloidal particle and discharged and coagulate and precipitated, discharged and precipitated. And the action of different electrolytes in a particular colloid is different. And the extent of the coagulation depends upon the nature of the electrolyte which we are adding into the colloid. And the effect of different electrolytes on coagulation was given by two scientists, that is, one is Hardy and Schulz. Hardy and Schulz. So according to Hardy and Schulz rule, higher the valency of the ion, higher the valency of the ion, higher will be the fluctuating power, or higher will be the precipitating power. For example, consider we have a negative colloid and we are going to add some positive electrolytes into it. So if we have an electrolyte containing Al3 plus ions and another electrolyte having Na plus ions, and one of the electrolyte contain Ba2 plus ion, the flocculation or the coagulation is easy when we add Al3 plus ions into this. Then next to Ba2 plus ions and then Na plus ions. That is, higher the valency of the ion, higher will be the precipitating power. Same way, if I need to precipitate a positive colloid, then I have to add negative electrolyte. So consider I have FeCN6 4 minus ions and then electrolyte having PO4 3 minus ions and SO4 2 minus ions and another one containing Cl minus ions. So coagulation will be easy when we add electrolyte containing FeCN6 4 minus. Next PO4 3 minus and then SO4 2 minus, and the least will be for Cl minus ions. And the minimum amount of electrolyte, which is required to precipitate a colloid, which is required to precipitate a colloid is known as flocculation value. So greater the flocculation value, so greater the fluctuating power, lesser will be the flocculation value. Okay, this is all about Hardy and Schulz rule.